A tiny frozen world 3 billion miles away is doing something no fitting model saw coming, and every telescope we train on it seems to come back with a different answer. We were told its thin nitrogen sky was about to collapse by the year 2030, and the teaching charts called it the next great vanishing act at the very edge of the sun's family. Stick around, because the truth is the opposite of what they expected, and it lives in the slow way starlight bends around frozen air, in the pale tick of a heart on a dead world, and in a sky that should not be there at all. Subscribe here if you want the next paper readout delivered to your feed before your friends hear it on the evening news. Picture a ball of rock and ice, smaller than our own moon, drifting alone on the very fringe of the sun's reach, holding on to a sky that should not exist. Picture that sky as a thin shell of gas about 10,000 times thinner than the warm breath leaving your lips on a winter morning. Let us go back to where this story actually begins, because the scene has to be set before the surprise can land. Most people believe Pluto is just a dead ball of rock floating alone in the dark. They picture a quiet, frozen rock that has been quiet for billions of years and will stay quiet for billions more. That picture is wrong on its face. Pluto has seasons. Pluto has weather. Pluto has a sky. And most surprisingly of all, that sky is alive and changing in directions that the old textbooks never predicted. We will see why in just a few minutes. It all started on a winter night in 1930. A young man named Clyde Tombaugh, working at the Lowell Observatory in Flagstaff, Arizona, found a moving point of light on two photographic plates taken on January 23rd and January 29th of 1930. He was hunting for Planet X, an object predicted by Percival Lowell decades earlier. Tombaugh was only 24 years old. He had grown up on a farm in Kansas and built his own telescope by hand as a teenager, grinding the mirrors himself from parts he had salvaged. The discovery was announced on March 13, 1930, the 75th anniversary of Percival Lowell's birth. Schoolchildren across the United States voted months later to name the new world Pluto, picking the Roman god of the underworld partly because the letters P and L match Lowell's initials. That is how the most famous rock in the outer solar system joined the family of known worlds. For most of the 20th century, Pluto stayed as a fuzzy dot in the world's strongest telescopes. We knew it was small. We knew it was slow. We knew it had a strange, stretched orbit. We did not know whether it had atmosphere, weather, or even whether its surface was solid or something stranger. Most guesses in textbooks ran toward a cold, crater-pocked ball, more like Neptune's moon Triton than anything else. And that meant the default assumption about its air was simple. There probably was none worth mentioning. Whatever thin gas the distant sun might lift from the surface would freeze and fall before it could ever build a real sky. That was the working story for nearly 100 years. That was the working story written in chalk when the parents of today's Pluto scientists sat in their own classrooms. The first surprise came in the summer of 2015. A small spacecraft called New Horizons, built by the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, and managed by NASA, crossed nearly 3 billion miles of empty space and flew past Pluto on July 14, 2015. The team leader is Alan Stern, a planetary scientist at the Southwest Research Institute in Boulder, Colorado. The whole mission cost about $700 million. Think of that, the price of a few large sports stadiums, flown across our entire solar system to take pictures of a tiny ice ball. The flyby was the fastest spacecraft ever launched from Earth. New Horizons left the planet at roughly 36,000 miles per hour, close to 15 times faster than a rifle bullet. The closest pass brought the spacecraft within about 12,500 kilometers, or roughly 7,800 miles, of Pluto's surface. That is closer than the distance from New York City to Paris, ticked off in under a second. The instruments aboard that small probe are worth knowing because we will run into their findings many times in this story. There is Lori, a long-range camera that sees in black and white. There is Ralph, a color imager and infrared mapper. There is Alice, an ultraviolet spectrometer. There is Rex, the radio experiment that used signals from Earth itself to measure the density of Pluto's air. There is SWAP, a solar wind detector. And there is Pepsi, an instrument that counts energetic particles flying off Pluto. 7 small, careful tools, all running on a single radioisotope power source that puts out about 200 watts of electricity. That is roughly the same as the power from 2 old-school incandescent light bulbs sitting on a kitchen counter. What those instruments found shocked the room. Before the flyby, scientists expected a cold, smooth, frozen surface, dark and quiet. Instead, New Horizons found mountains of water ice standing 2 miles tall, taller than anything in the state of Colorado. A vast, flat glacier of nitrogen ice the size of Texas, named Sputnik Planitia, filled the western half of a giant heart shape on Pluto's surface. The texture of that glacier looked like wind-blown mud on a calm afternoon. There were dunes made of frozen methane particles that should not have had enough atmosphere to form. There were pits and troughs that looked like they were still moving. The scientists walked into that flyby expecting a museum piece. They walked out holding evidence of an active world. That heart shape on Pluto's surface also convinced mathematicians to look once more at what might be happening underneath. In 2016, a team led by Francis Nimmo at the University of California, Santa Cruz, working with researchers from MIT, published a paper in the journal Nature, arguing that Sputnik Planitia's weight could keep a deep ocean of salty water turning slowly beneath the ice shell. Their model said the ocean might be hiding about 100 kilometers down, deeper than the deepest trench in our own Pacific Ocean. If true, Pluto could be hosting the most distant liquid water ocean we know of in the entire solar system. That would mean this frozen little world is doing the very same thing some of Jupiter's moons are doing, except nobody expected it. Ammonia mixed into the water would act like an antifreeze inside your kitchen radiator, keeping the deep ocean liquid even at temperatures well below the freezing point of pure water. The second finding changed everything we thought we knew about cold worlds. Pluto has a sky, and that sky is blue. Cameras on New Horizons, run by a team including Bonnie Barati of NASA's Jet Propulsion Laboratory in Pasadena, captured thin layers of haze in Pluto's atmosphere that stretched 100 miles above the surface. 20 separate layers of haze, stacked like onion rings across the sky. The backlit haze was first spotted in images sent back in the days after closest approach. The blue tint is caused by the same kind of light scattering that makes our own sky blue, except the haze particles are not water droplets. They are the broken remains of methane molecules hit by ultraviolet light from the distant sun. The pressure at Pluto's surface is about 10 microbars, roughly 10 millionths of the air pressure on a beach at sea level on Earth. Imagine a kitchen refrigerator. The little light bulb inside a refrigerator uses about 4 watts of power. The push of Pluto's whole sky is far softer than the breath of a child on a winter morning. That is how delicate this air is. Before we go deeper, here is a question I need to put to you. What single measurement would you want a probe to make first if we ever land on Pluto? Comment below with your best idea, because your comment helps me understand which corners of space exploration you most want me to cover next, and it tells me which pieces of the story deserve a deeper dive. The third discovery puzzled scientists the most because it was the one they had the firmest prediction about. Pluto's orbit takes 248 years around the Sun. That orbit is not a clean circle. It is a stretched ellipse. Pluto's axial tilt, the way the world leans over as it spins, is around 120 degrees. That is so far over that Pluto is essentially lying on its side as it travels. Between 1989 and 2015, Pluto was actually moving closer to the Sun, even though it is still nearly 3 billion miles away at its closest point. After 2015, Pluto began drifting farther out, and it will keep drifting outward for another century and more, until the year 2114. Perihelion, the closest point in the orbit, was reached in September 1989. We are past that moment. Pluto is now in the slow, fading half of its year. That is exactly the half the textbook said would freeze the air out. As Pluto moves away from the Sun, sunlight weakens. The surface cools. The gas above the surface cools too. That gas falls as frost, leaving a thinner atmosphere. The thinner atmosphere traps less heat, so the surface cools faster. This is a chain reaction. On most small cold worlds, like Mars during its long winter nights, this chain runs all the way down to nothing. The air freezes. The sky disappears. The sky comes back only when spring returns, 20 years later. Pluto was supposed to run out of air. It was not. That is the puzzle. In 2019, a team led by Yi Yuan at the Yunnan Observatories of the Chinese Academy of Sciences published a paper in the journal Astronomy and Astrophysics. They had watched a star wink out behind Pluto on September 5, 2019, a careful technique called a stellar occultation. The way Pluto's air bends the star's light tells you how thick the air is. Their reading said the pressure was higher than expected. In 2020, on August 23rd, a team writing in the Planetary Science Journal, led by B. Nealing, found something similar. On August 23, 2022, another stellar occultation was followed by another team, led by A. Sisyphus, and they concluded the pressure had stayed roughly flat since the New Horizons flyby. 3 independent groups, on 3 different continents, with 3 different telescopes, all landing on the same odd agreement. The air was not freezing out. It was hanging on. Each of those measurements required something close to 40 telescopes working in coordination across several countries. When something so delicate is measured again and again and returns the same surprise, the surprise tends to be real. The Royal Astronomical Society has discussed this strange standoff publicly, and the scientific paper trail now stretches across the journals Icarus, the Astronomical Journal, and Planetary Science Journal. We have right now a community that has built a strong case that the textbook story is wrong, even though the field has not yet settled on a clean replacement story. That is the kind of moment scientists live for, even if it means more work. The leading explanation for this stubborn error is not what most people would expect. It is called the thermal lag idea. Pluto is slow to feel the cold. Its surface is covered in bright nitrogen ice, which reflects most of the sunlight that hits it, and the small amount of heat it does soak in takes a long time to leak back out into space. Think of a frozen pizza fresh out of the freezer. If you set it down on your kitchen counter, it does not warm up in seconds. It warms up over an hour or more because the cold runs deep inside the dough and slowly spreads outward. Pluto is doing that in reverse. The cold is moving in. The ice and the gas are not ready to give up their warmth. Researchers including P.E. Johnson, writing in Icarus in 2021, ran models of this exact problem and found that the minimum pressure in Pluto's current orbit could be anywhere between 1/10 and 3 times what we measure now. That is a huge range. The models admit they do not know how cold Pluto will actually get. There are 4 moving parts to this little world, and they all interact with each other in surprising ways. We have the haze, which is supposed to be passive but may be glowing. We have the thermal lag in the surface, which slows the cooling. We have the nitrogen ice on the surface, which keeps turning directly into gas in some seasons. And we have the long 248-year orbit and its wild axial tilt, which means the northern half of Pluto has been on the sunny side of the world for 100 years at a stretch. These 4 parts together are what is keeping the air aloft. Take one piece away and the math collapses. Together, they are holding up a sky that should not be there. Here's a question for you before we carry on. Of all the things scientists have found about Pluto since 2015, which one would you pick as the most surprising? Like this video if you want this channel to keep bringing you slow, careful stories from the outer solar system, because liking tells the YouTube system that this kind of patient science writing has a real audience waiting for it, and that signal helps the right kind of stories find the right kind of viewers. Now layer in the haze, because the haze changes the math in a strange way. The 20 blue layers floating in Pluto's sky are made when ultraviolet light from the sun hits methane in the upper air, breaking the methane molecules apart and letting them reassemble into heavier particles, the way broken glass reforms in crystal patterns on a quietly empty shelf. Andrew Ingersoll of the California Institute of Technology in Pasadena, working with the New Horizons team, measured these haze particles and found they are about the size of grains of soot on a fireplace window. Those grains float down slowly through the air. As they fall, they release heat. The haze acts like a thin blanket over the air. On a cold morning, a single blanket over your bed makes a noticeable difference. 20 layers of haze in Pluto's sky may be doing the same job for the entire air, slowing the collapse by giving back heat on the way down. Catherine Olkin of the Southwest Research Institute, who led an early paper on this haze effect published in 2013, said the sky behaves more like a living system than a quiet lid. The haze also wraps the sky in colors we did not expect. Pluto's sky is blue by day, but the haze layers pick up a faint reddish glow at sunrise and sunset. That tint comes from the same kind of chemistry that makes smog turn red over a city at dusk, except the chemistry happens 40 times farther from the sun than we get in our own big cities. Understanding exactly how that reddish glow changes with the seasons will take years of patient work. Pluto's slow seasons mean Pluto's sky changes at the pace of a steady family movie, not a fast music video. The pressure picture keeps getting stranger. Between the summer of 2015 and the year 2019, ground-based measurements by teams using telescopes in Hawaii, Chile, and Australia suggested the pressure was holding steady or slightly rising. Then, in the years after 2019, some readings pointed the other way. Leslie Young of the Southwest Research Institute, who leads the Atmospheric Science Working Group for New Horizons, said in a 2024 briefing that the pressure had been at least double the lowest predictions. A paper published in Icarus in 2023 by Yao and his co-authors added yet another wrinkle, suggesting nighttime cooling on Pluto could refreeze part of the atmosphere at certain times of year. So we have a story that goes both ways 5 years apart and then settles into a strange, steady state that the models do not fully explain. That is the kind of disagreement that wakes up scientists at night, and for good reason. Stand back for a moment and think about the distance we are talking about, because the scale of the puzzle sets the whole mood. Pluto sits roughly 40 times farther from the Sun than Earth does, and on its average day, around 3.25 billion miles out. Light from the Sun takes about 5.5 hours to reach it. Compare that to the 8 minutes and 20 seconds sunlight takes to reach Earth. Pluto is so distant that the heat it gets from the Sun is roughly the same as the heat your kitchen stove loses to the back of a cold wall on a winter day. Almost nothing reaches it. And yet a thin nitrogen sky still hangs over it. That is what makes this particular story worth telling. Now imagine you are standing on Sputnik Planitia at local noon, and use the word local very loosely. The temperature outside is around minus 229 degrees Celsius. Scale that to a calendar. If the warmest the surface gets is a single day in a year that is 248 of our Earth years long, you can feel the strangeness in your chest. The wind is slow because the air is so thin that it barely pushes. The sky overhead is black, but a thin blue ring hugs the horizon, because the layers of haze scatter the dim sunlight before it travels higher. You would be standing in a place where ice on the ground does not behave the way ice behaves in your kitchen. Nitrogen ice on Pluto sublimates. It turns directly from solid into gas, the way dry ice does in a punch bowl at a quiet party. The brightness of that sky also tells you something about time. The Sun, from the surface of Pluto, looks like a bright dot about 1,000 times dimmer than our own Sun at noon. Shadows, if any of the soft light reaches your feet, are pale. Walking across Sputnik Planitia would feel like walking across the floor of a softly lit dining room at the back of a long hallway. Everything is dim. Everything is blue, and everything is moving in slow motion. Now a question for me to put to you. Who in your life loves a slow-burn space mystery and has never heard the Pluto story told this way? Share this video with that friend, because sharing helps the video reach people who genuinely need to hear this story of an underestimated little world pushing back against its own headline. Now let us bring in Pluto's companion, because the picture is not complete without its largest moon. Charon was discovered in 1978 by James Christie at the United States Naval Observatory in Flagstaff, Arizona, just a few miles from where Clyde Tombaugh had hunted Pluto decades earlier. Charon is about 1,200 kilometers across, roughly half the diameter of Pluto itself. That is huge in moon terms. Our own moon is about a quarter the size of Earth. Charon and Pluto are closer to siblings than to a planet and moon pair. The two face each other in mutual tidal lock, the same way our moon always shows us the same face. Only here, both faces are frozen toward each other, and Pluto's largest moon does the same thing in return. They never turn away from each other, ever. That mutual tidal lock makes the pair act like a slow dance. Both bodies circle around a shared balance point called the barycenter. The barycenter is not inside Pluto. It sits in empty space between the two worlds. That is rare in the solar system. Earth and the moon orbit a barycenter that is still inside the Earth. Pluto and Charon orbit one that floats above the planet's surface. The difference is real. It means Pluto and Charon are closer to a true binary system, and the way they tug on each other shapes much of the strange motion and stress on Pluto's surface. The Charon half of New Horizons' mission happened minutes after the Pluto flyby. About 13 minutes after closest approach to Pluto, the spacecraft passed within about 18,000 miles of Charon. That lucky timing gave us our first close look at a moon that is itself nearly the size of Pluto's twin. Charon turned out to be a cratered ball of water ice with dark stains around its north pole, stains that scientists now call Mordor macula. The dark color is believed to come from tholins, the same kind of complex carbon compound that paints the haze over Pluto. There are also 4 smaller moons that we know about, named Nix, Hydra, Kerberos, and Styx. Each one is small, jagged, and spins in a strange way because of the gravitational pull of their 2 larger siblings. Their colors and spin patterns look like the rubble of a long-ago collision. That collision probably carved Pluto's heart shape itself by slamming a large object into Pluto once upon a time. Estimates from a 2020 study pointed to a roughly 400-mile-wide impactor hitting at about 30 degrees. That single collision may have shaped almost everything we now see on Pluto's surface. One slow-motion crash billions of years ago left us today with the missing half of a heart pattern. There is one more piece of this puzzle worth naming out loud. Pluto was demoted from planet to dwarf in 2006, only months before New Horizons was even close to its target. The list of 9 planets shrank to 8. School textbooks got rewritten. The scientists who had argued for keeping Pluto planet status felt pushed aside. The scientists who had argued for the demotion felt vindicated. New Horizons turned all of that on its head in just 10 hours of close observation in 2015, when pictures from the spacecraft showed active geology, blue skies, and a strange beating heart on its surface. The International Astronomical Union, the same body that demoted Pluto, did not reverse the call. But some adults who saw the pictures as teenagers are now designing Pluto missions for NASA and the European Space Agency. The whole story has the quiet justice of an underdog story. A kid who was told he was not good enough won the science fair. Now let us bring the telescope story up to date, because most public discussion of Pluto ends with the year 2015, and that is a mistake. The James Webb Space Telescope, the gold-plated giant of orbital observatories, took its own look at Pluto's atmosphere in 2023. A team led by Tanguy Bertrand at the Space Telescope Science Institute in Baltimore published measurements that suggested the haze layers are themselves emitting a faint glow at mid-infrared wavelengths. The result, summarized in a 2024 publication in association with the European Space Agency, surprised people because haze is supposed to be passive. It is supposed to drift, react to sunlight, and fall. If the haze is glowing even a little on its own, it is no longer passive. It is interacting with the air around it. And that small change in behavior could keep the atmosphere alive for decades longer than anyone expected. The mystery here is not a single funny moment. It is a long, slow process. Think of the gap between a match striking and a slow-cooked dish finishing 12 hours later. The Pluto puzzle has been simmering since at least 2013, when Olkin and colleagues first showed the air held on at perihelion. New Horizons gave a single snapshot in 2015. The community has been watching the air with ground telescopes through stellar occultations ever since. Every 2 years, roughly, a major occultation event lines up with the path across Earth, and every 2 years we get a deeper reading. The next big one researchers are watching is the occultation on September 24th, 2026, when Pluto's shadow will sweep over a band from the southern Indian Ocean to South America. We have not seen that one yet. We will, right here on this channel, when its numbers land. What does this mean for the next chapter? The short answer is more watching. NASA does not yet have a second Pluto mission on its books. The European Space Agency's Pluto probes are still under study. Ground-based telescopes and the James Webb Space Telescope will keep scanning Pluto's shadow as it slides in front of stars, and each pass gives the community a fresh reading. In a 2025 review paper led by Bruno Siccardi, published in the journal Astronomy and Astrophysics Review, the team laid out a roadmap for resolving the disagreement. The roadmap will take years. That is fine. Some mysteries are solved in a summer. Others are passed from one generation of graduate students to the next, like an unfinished family puzzle on a kitchen table. Here's my last question before we close. What part of this puzzle would you most like explained in the next video? Comment below with the one piece of this story that bugs you most, because your comment helps me decide which slow, careful science story I should chase after next, and it tells me where the open questions still need a guide. Now for the part that matters most. Most of what we just walked through started from the same premise, that Pluto was a frozen rock that had run out of surprises. We took that premise apart. We showed that the mountains of water ice are real. We showed that the heart shape is an active glacier. We showed that the haze floats in 20 layers across a blue sky. We showed that the pressure has not collapsed. We showed that the haze itself might be glowing in a way nobody predicted. We did not prove every claim with certainty. Science rarely does that with active mysteries. We did show that the headline answer was too simple, and that the real Pluto is far more interesting than the tired textbook version. That is the gift that comes from watching a story like this one slowly unfold. Let us end where we began. We started with a tiny frozen world doing the thing no model predicted. We started with the idea that a thin nitrogen sky was about to disappear, that what was once taught as fact is now studied as a puzzle. We started with a contradiction. And now, after walking through mountains made of water ice, through dunes made of methane, through a haze that may glow on its own, through thermal lag, through mutual tidal lock, and through at least 3 different measurements from 3 different teams across 3 different continents, the contradiction has not been resolved. It has deepened. The little world has earned its place among the strange, alive places of our solar system. There is a final image I want to leave with you. Picture Pluto from above. Look down at Sputnik Planitia. Listen to the silence of that place, because the sound of nothing in the outer solar system is the loudest sound we can hear from this part of space. There is nothing but the slow sizzle of nitrogen turning directly to gas, the slow drift of haze toward the ground, and the slow sunlight arriving 5.5 hours late after leaving a star that looks like nothing more than a bright dot at the edge of a porch. In a place that should not have an atmosphere, there is an atmosphere. In a place that should freeze over, it is not freezing over. In a place that should be quiet, there is motion. And we, the people with kitchen tables and kitchen lights and kitchen sinks, are the only ones watching. We are listening to a sky that should not exist. We are listening to a heart on a frozen rock. We are listening because we choose to, and that is the part of the story that has not yet been written. Few knew this story before tonight. Now we all need to listen. Carry that with you. When you walk past your kitchen stove tomorrow morning, or open the refrigerator door, or watch the steam rise from the kitchen sink, remember that somewhere 38 times farther than you have ever flown, there is an ice heart 10,000 times thinner than the air you are breathing, and it is still beating, still breathing, still surprising the people who told us it could not last much longer. So listen to it, the way you would listen to a slowing metronome in the next room. Trust me on this one. It is more important than you think. It deserves a place on your kitchen table in the morning.